Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. A bug bounty program is an organized way for a company to invite independent security researchers to report real weaknesses in exchange for recognition or payment under agreed rules. The idea is simple yet powerful because many skilled people can look at systems from fresh angles and find issues internal teams missed during routine work. These programs run continuously or in defined windows, which means security gets tested when code changes and not only during scheduled audits. Companies publish rules, set safe boundaries, and promise not to pursue good faith researchers who follow them, which builds trust and encourages responsible behavior. Researchers, in return, share clear details that help teams reproduce, fix, and learn from problems without public harm or surprise. Together, these elements create a structured marketplace for risk discovery that rewards careful reporting and timely remediation. A bug bounty program differs from traditional penetration testing and a basic vulnerability disclosure policy because it combines open participation with defined rewards and ongoing cadence. Traditional penetration testing is a contracted, time-boxed assessment where a hired team follows a plan and delivers a report to a single customer. A vulnerability disclosure policy, VDP, is a public statement that explains how to report issues safely, yet it usually offers thanks rather than payment and may not include organized triage or rewards. Bug bounties add incentives, formal intake workflows, and repeated opportunities for discovery across code changes and new features. Many organizations run all three approaches together, using each for what it does best in the overall assurance mix. A beginner can think of bug bounties as a standing invitation to help improve security with clear rules and fair recognition. Several stakeholders make a modern bug bounty work, and each carries a distinct responsibility that supports clarity and speed. Program owners define business goals, set budgets, choose platforms, and ensure the rules reflect legal and operational realities across the company. Platform providers offer hosted workflows, researcher communities, duplicate detection, and secure communications while helping programs reach qualified participants efficiently. Triage teams evaluate incoming reports, reproduce findings, assign preliminary severity, detect duplicates, and route issues to the right engineering groups. Independent researchers investigate within published scope, share high-quality write-ups, respond to questions, and respect boundaries set by the program. When these roles coordinate smoothly, submissions move quickly from discovery to decision, which keeps researchers engaged and reduces open risk windows for the organization. Clear scope and rules are the foundation of trust, so programs write them with precision and unambiguous language. Rules of engagement, ROE, specify in-scope assets such as domains, applications, and versions, while listing out-of-scope areas that should never be touched. Prohibited techniques might include denial of service, social engineering against employees, or accessing other customers' data under any circumstance. Safe harbor language promises that the organization will not pursue legal action against good faith research within the rules, and encourages immediate reporting if sensitive data is encountered. Programs also clarify time windows for testing, identity requirements where applicable, and whether staging environments or special accounts are available. By removing guesswork up front, companies empower ethical testing while protecting reliability and user trust. Severity and reward systems motivate quality findings and ensure consistent, transparent payouts tied to real risk rather than hype. Many programs map impact to the Common Vulnerability Scoring System, CVS, then adjust tiers by business context. So high-value assets and chained exploits receive appropriate consideration. Reward structures may include cash bounties for impactful issues and kudos-only recognition for low-risk findings, along with rules for duplicates and first-to-report outcomes. Programs publish minimum and maximum ranges to set expectations, note exceptions for extreme cases, and describe processes for handling disputes fairly. Payment logistics cover identity checks, tax considerations, and timelines so researchers can plan and trust the process. When the model is clear, researchers target meaningful weaknesses and spend more time reproducing, proving, and documenting them well. Every valid submission travels a predictable path from intake to closure, and well-run programs make each step visible and timely. The life cycle typically begins with a structured report that includes a concise summary, a proof of concept, POC, reproduction steps, and expected versus actual behavior. Triage verifies the claim, tests in a controlled environment, checks for duplicates, and proposes an initial severity so engineering can size the work. Engineering prioritizes the fix, applies changes, and coordinates tests with quality teams to ensure the issue is truly resolved without breaking other functionality. After validation, the program issues a payout if applicable, closes the report with clear notes, and schedules coordinated disclosure when it is safe and agreed. This rhythm builds mutual confidence because everyone sees progress from discovery through learning. Legal and ethical foundations protect people, data, and organizations while enabling honest research under defined boundaries. Programs reaffirm authorization in scope pages and explain that tests must not access other users' accounts, sensitive production records, or any data beyond what is necessary to prove impact. Many include guidance for handling accidentally accessed information, such as personally identifiable information, PII, requiring immediate reporting, limited access, and secure deletion after confirmation. Terms of service, TOS, export limitations, and jurisdiction notes clarify how national or local laws may affect researcher participation. Safe harbor commitments reinforce that good faith work within rules is welcomed, while actions outside boundaries may be unauthorized and risky. Ethical tone matters because respectful language sets expectations for careful testing, responsible reporting, and patient communication. Preparation determines success at launch, so organizations do groundwork that removes friction before the first report arrives. Asset inventories identify which domains, APIs, and applications truly exist and who owns them internally when a fix requires action. Service-level agreements, SLAs, for triage and engineering set honest timelines for first response, severity decisions, fix targets, and researcher updates. Logging, monitoring, and alert routing ensure teams can validate claims quickly and observe effects without guessing across noisy systems. Communications readiness includes clear mailboxes, templated responses, and escalation paths so unusual cases receive fast and consistent treatment. When these pieces are ready, early submissions turn into constructive wins rather than frustrating delays that discourage participation. Choosing where and how to run a program depends on goals, scale, and available capacity rather than fashion or peer pressure. Public platforms offer access to large researcher communities, mature workflows, and helpful analytics, which shortens time to first result for many organizations. Private or invite-only programs limit participation to selected researchers, which reduces noise and can focus attention on complex systems or sensitive environments. Self-hosted programs offer maximum control, brand alignment, and lower platform fees, yet they require dedicated tooling, intake security, and community management efforts. Selection criteria often include budget, expected researcher pool, required integrations, and tolerance for managing disputes and outreach. A clear rationale keeps choices grounded in risk and resource reality rather than assumptions. A good policy page is a practical guide for helpful behavior, so it favors clarity over slogans and exhaustive legalese. It explains how to report, which channel to use, and what details make a submission actionable, including steps, affected versions, and minimal POC instructions. The Scope section lists in-scope assets, out-of-scope areas, testing limits, and uptime expectations for production or staging. Programs describe duplicate handling to avoid wasted effort, and they outline disclosure timing so researchers understand when write-ups may be shared. Where appropriate, sample report templates reduce guesswork and raise quality by showing the exact structure reviewers expect. The result is fewer back-and-forth messages and more time spent fixing meaningful issues. Operational triage practices transform raw submissions into high-quality engineering tickets with consistent evidence and clear impact statements. Teams verify reproducibility on fresh accounts or clean environments, capture screenshots or logs, and record the minimum steps needed to reach the vulnerable condition reliably. Severity negotiation occurs when context changes the risk picture, and respectful explanations help researchers see the business perspective behind adjustments. Duplicate detection tools and careful searches prevent unnecessary payouts and keep focus on novel findings rather than repeated noise. Service Level Agreement, SLA, tracking and templated updates maintain momentum and demonstrate that the program values researcher time. Transparent, prompt, and courteous communication is often the difference between a thriving program and a discouraged community. Integrating bounty insights into core development and security work prevents the same issues from reappearing under slightly different shapes. Teams connect validated reports to existing ticketing systems, mark root causes such as missing input validation or broken authorization, and capture the code locations involved. The software development lifecycle, SDLC, benefits when lessons become checks in code review guidelines, automated tests, or secure coding standards that engineers reference daily. Application security engineers add patterns to threat models, tune linting rules, and calibrate scanners to catch cousins of the original flaw earlier. Training sessions for developers use anonymized examples from recent fixes so lessons feel relevant and concrete. Treating every fix as a learning artifact pays long-term dividends across product lines and teams. Programs stumble when vague scope, slow responses, or defensive tone drive away the very talent they hope to attract, which creates reputational harm and lost insights. Vague scope invites accidental boundary crossings, so specificity and practical examples keep testing safe and focused for everyone involved. Slow responses break trust because researchers cannot tell whether silence means rejection, confusion, or operational overload within the organization. Disputes over severity or reward amounts escalate when explanations are thin, so documenting rationale and offering respectful appeals reduces frustration. Skipping postmortems wastes chances to improve triage forms, reproduction steps, and internal fix pathways that shorten future cycles. Teams that review failures honestly usually build programs that age gracefully and earn steady goodwill. Bug bounties work best alongside other assurance methods because no single technique covers every angle or every moment. Structured testing, such as code review, threat modeling, and targeted audits, catches classes of issues that bounties might not surface reliably. Meanwhile, bounties excel at discovering surprising interactions, overlooked endpoints, and edge case exploit paths across real deployments. First safe steps often include publishing a clear vulnerability disclosure policy, VDP, defining honest response timelines, and preparing triage and fix owners with documented workflows. New researchers often begin by reading scope carefully, practicing respectful reporting, and honing small, reproducible findings that demonstrate care and credibility. When both sides move deliberately, bug bounty programs become a steady engine for learning and risk reduction. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.